Hey friends, this is Michael Boehm with Youth Apologetics Training. Today we're going to have a guest, Dr. Jason Lisle of the Institute of Creation Research. We're going to be talking about astronomy, the Big Bang, and a young Earth. As Director of Research, Dr. Lisle leads ICR's gifted team of scientists who continue to investigate and demonstrate the evidence for creation. He graduated summa cum laude from Ohio Wesleyan University, where he double majored in physics and astronomy. He earned a master's degree and a PhD in astrophysics at the University of Colorado. Dr. Lisle specialized in solar astrophysics and has made a number of scientific discoveries regarding the solar photosphere and has contributed to the field of general relativity. After completion of his research at the University of Colorado, Dr. Lisle began working in full-time apologetics ministry, focusing on the defense of Genesis. Dr. Lisle was instrumental in developing the planetarium at the Creation Museum in Kentucky. Awesome place, been there. Writing and directing popular planetarium shows, including The Created Cosmos. Dr. Lisle speaks on topics relating to science and the defense of the Christian faith using logic and correct reasoning. He has authored numerous articles and books demonstrating that biblical creation is the only logical possibility for origins. Some of these books, guys, I own many of Dr. Lisle's books. The Ultimate Proof of Creation, Resolving the Origins of Debate, awesome book. Discerning Truth, Exposing Errors in Evolutionary Arguments, again, awesome book. Stargazer's Guide to the Night Sky, don't have that one yet, but I want it. Taking Back Astronomy, The Heavens Declare Creation, amazing book. A lot of things we're going to talk about, many of the things we're going to talk about tonight will be found in that book. Awesome book. Why Genesis Matters, The Solar System, God's Heavenly Handiwork. He also has a DVD, Astronomy Reveals Creation. Guys, and he has so many articles online. A very distinguished guest tonight. I'm very excited. Dr. Jason Lisle, welcome to the Youth Apologetics Training Podcast.
Oh, well, thank you for having me on. I appreciate it.
So, friends, again, like I was mentioning in the introduction, tonight we want to talk about the origin of the universe. Was it somehow born into existence through natural causes via some kind of a Big Bang 14 billion years ago? Or was it created by our God, the God of the Bible, 6,000 years ago? So I guess let's start off with, Dr. Lisle, what is the Big Bang, and why do scientists believe that it actually occurred?
Okay, well, the Big Bang is a naturalistic idea of how the universe could come into existence, and it is atheistic in its origin, or at least in terms of its motivation for believing it. It's supposed to explain our existence without invoking God, without invoking creation, without invoking miracles or the supernatural. And a lot of scientists believe in it for that very reason, because many scientists have a materialistic or naturalistic worldview. That is, they don't think that God exists, or if they do think that God exists, they think He doesn't do anything, and so that miracles can't occur and so on. But of course, I'm a scientist, and I reject the Big Bang, and I have some scientific reasons to reject it. I have some philosophical reasons to reject it, and I have some biblical reasons to reject it. But I just want to make that clear right at the outset. It is a naturalistic idea. And basically the story, and it is a story, it goes something like this. The idea is that originally there was nothing, and other than, I guess, a singularity, which is basically a point with nothing around it, a single point of no size at all, and all of the material in space, and even space itself, is packed into this point, this singularity, which then for some reason rapidly expands. It sort of explodes out and expands like a rapid balloon, and that carries all the material that's packed into that point, all the space that's packed into it. It carries it out, it stretches it out, expands into a very large region. And so in the Big Bang idea, the universe started out smaller than an atom, and it has rapidly expanded. And this process allegedly takes, well, to get to the current size of the universe, it allegedly takes 13.8 billion years is the latest number they put on it.
Oh, wow.
Yeah, and the reason they put that number on it, by the way, that comes from the fact that we do see evidence that the universe is getting bigger. It's being expanded out. And my secular colleagues assume that that is sort of the leftover energy from this initial explosion. And so working it backwards, they can't go back beyond 13.8 billion years because everything would be in the same place at the same time. And so that puts an upper limit on it. But the idea then is all this material, as it's expanding out early in the Big Bang, it's incredibly hot, incredibly high temperatures, because when you pack a lot of stuff into a small space, it creates heat. I don't know if you ever remember pumping up your bike tire. You put all that pressure in it, it heats up. It actually, you can feel it getting warmer. So the Big Bang would have temperatures that are almost essentially infinite. And you can't even have matter at that temperature, so it'd just be what we would think of as pure energy. And as it cools, some of that energy becomes matter. It becomes hydrogen and helium, the two lightest gases. And some of those gases collapse into stars, and then stars accumulate into galaxies. And this is all supposed to happen by itself, without any God, without any sort of creative insight into it. And then some of these stars explode and make some of the heavier elements, and those act as seed for planets. And the idea is that our sun is really a third-generation star. It's been recycled from other stars basically 3 times, and that our planet is left over from the explosion of these stars. And so basically everything that is in our universe today is allegedly the result of this initial Big Bang. So that's the Big Bang in a nutshell.
Okay, wow, fascinating. So basically it started 13.8 billion years ago, according to the modern understanding. And we had this singularity, this little dot. It got hot. It started spinning around and exploded. And we ended up with all the matter and everything that we see from that explosion. But I guess it started with hydrogen and helium. And I read in one of your books a little bit of lithium.
That's right. That's right. Those are the 3 lightest elements, basically. Only tiny amounts of lithium. It's mostly hydrogen and helium.
So how do we end up with all the other elements? Exactly.
That's actually a problem that the Big Bangers sometimes, I think, keep from laymen. But the Big Bang, because sometimes, let me back up a little bit. I should explain that sometimes you'll hear people say, well, the ratio of elements that we have in the universe, the fact that we have lots of hydrogen and less helium and far less of these other elements, is evidence for the Big Bang. That is, the Big Bang predicted those ratios. That's not really true. Those ratios were known at least approximately before the Big Bang was invented. But in any case, the Big Bang can only explain the existence of the 3 lightest elements. The other 90 or so naturally occurring elements, they can't be produced in a Big Bang. And that was one of the problems in secular views of astronomy for quite some time. And then astronomers thought that, well, maybe stars then can produce these heavier elements. The idea is that when some stars explode, we know that that's true because we see stars occasionally explode. That's called a supernova. And it's believed that when these supernovae happen, the conditions in the core of that star are sufficiently hot and with sufficient pressure and density to produce the heavier elements, oxygen, nitrogen, carbon, the stuff that we're made of. And so the idea is stars take over for the Big Bang, and they make the remaining 90 or so naturally occurring elements. But the Big Bang can only explain the existence of the first 3, and it really can't explain those, not rationally. But my point is, even the secularists will admit it can't account for the remaining 90 or so naturally occurring elements.
And okay, and you're touching on the population 3 stars, right? Like, shouldn't we? Is that what you're referring to?
Yeah, it is. And that's actually a problem with the Big Bang, because according to the Big Bang model, since the Big Bang can only produce these 3 lightest elements, hydrogen, helium, and just tiny amounts of lithium, the first stars would have to be made of only those 3 elements and nothing else, because there wasn't anything else. The Big Bang can't produce anything else. And according to all that we understand about physics, the coolest stars, the red dwarf type stars, ought to be able to last much longer than 13.8 billion years. They have sufficient fuel and they burn it at such a slow rate that they should be able to last much longer than that, which means we ought to see stars in the universe today that have, at least some stars, that have no of these heavier elements, none of the heavier elements, no oxygen, no nitrogen, and so on. And these are called population 3 stars. That's the name for stars that would be expected if the Big Bang were true. And the interesting thing is we find not one population 3 star anywhere in the universe. I think that's a devastating problem with the Big Bang, because you'd expect these stars to exist if it were true, and we find not one. All stars that we know of have at least some heavier elements in them, some oxygen, nitrogen, carbon, and so on. Now, stars don't have a lot of those things, but my point is, if the Big Bang's true, you'd expect to have population 3 stars, which would have none of those elements, and we just don't find those stars anywhere in the universe.
Right. Now, how do stars form, according to the modern theories of science?
Yeah, well, that's another problem, I should say, for the secular models. And again, it's not I'm a scientist, and I believe in the methods of science. But once you talk about what allegedly happened a long time ago and how things came to be, you're not really doing science at that point. So it's not really what science says about star formation or the universe formation, but the question on many people's minds are what do secular scientists often believe about that? And the answer is they believe that the gas that was produced in the Big Bang, the hydrogen and helium, collapsed in on itself in certain places to form stars. And so the idea is that the gravity from all those atoms pulled them together to make a star. And that really is very problematic. And the reason it's problematic is because gas tends to expand. When you walk into a room, you don't hold your breath just in case all the air should go to one corner of the room. You expect that the air will spread out and fill its container. That's something that elementary school students learn, is that gas fills its container. And in space, there is no container, so gas just expands infinitely. It wants to keep expanding and expanding. Now, theoretically, once you make a star, God can make a star and pull that gas so close together that its gravity eventually takes over. And that's why the sun doesn't expand into space. It's made of gas, but its gravity holds it together. But that only works if the star is already small. When gas is distributed in space, the pressure of that gas is much, much greater than the force of gravity within that gas. And so it's actually problematic as to how you could get stars to form in the first place. And this is something, by the way, that is acknowledged by secular astronomers. They know that there are problems with their models of star formation. And some of their latest ideas are that the only way you could possibly overcome that gas pressure is to have previous stars explode, and that creates shock waves. And they think that maybe that could get up enough pressure that you could overcome the gas pressure and cause a star to form, cause a star to actually start forming. And I hope you see that there's a chicken and an egg problem there, because, if you need previous stars to make new stars, well, how did you get the first stars? That's what I'd like to know. And, of course, biblically, I would say, as I'm a Christian and I'm a scientist, of course, but I believe that God created the first stars, and everything that I've seen in the universe is consistent with the idea that stars really don't form. And I know that may shock some people, because you'll read in newspapers, this is a star-forming region or whatever, but no one has ever seen a star form. No astronomer has ever seen a star form. There are physical reasons to think that maybe it can't even happen. I won't be totally dogmatic on that, but I think it would be very rare, because gas tends to expand, and it does not want to collapse in on itself. There are two additional problems, though, with star formation. Even if you could get the gas to overcome its gas pressure and start to collapse in on itself, there are two additional things that would tend to prevent star formation. One of them is the magnetic field. Gas tends to have a weak magnetic field going through it. Just all gas everywhere, really, because a lot of it's in a plasma state anyway. And so it's magnetic. And when you collapse it, that magnetic field, that magnetic energy increases. It's kind of like if you've ever taken two magnets and you try to push them together, north end to north end. Well, they repel. They don't want to push in anymore. And so a star would be like that too. Its magnetic pressure would want to cause it to re-expand and not to collapse in on itself. And then also there's the problem of angular momentum. A gas cloud, it's not going to be totally stationary. It's going to have just a little bit of rotation to it. And when you take something that's huge like a gas cloud and crush it together to something the size of a star, that spinningness is going to increase, kind of like a skater when she's spinning and she pulls her arm in and she speeds up. That was kind of amazing. That would make me sick to do that. But in any case, if a star's going to do that that angular momentum is going to want to then push the material back out again. And so those three things, gas pressure, magnetic fields, and angular momentum, all work against the idea that stars would just form naturally. Now, once you make a star, it's going to stay that way. That's fine. Its gravity will take over, and so you don't have to worry about the sun dispersing into space. But I think that stars probably don't form at all, or at least it ought to be very, very rare.
Okay. Now, skipping back to the secular worldview, what evidence do secular scientists grab a hold of to say that the Big Bang actually happened?
Okay, well, there are just a few lines of evidence that they would try to use to argue for that. Now, I don't think any of these are good, of course, but if you'd read a standard textbook, here's what they would argue. I think some of them would say, well, the ratio of the elements, and I've already mentioned that the Big Bang really didn't predict that. It's been worked backwards. You can work the math backwards to figure out what the conditions would have to be in the Big Bang to produce the observed ratio of and even then you can only get the three lightest elements. The Big Bang can't produce the rest. So I think that's a weak argument right there. They'll say, well, we observed expansion of the universe. And I say, yes, that's certainly true. I think the universe is expanding, and there's good evidence for this. But that doesn't mean that all the galaxies and even space itself were all in the same place at one time. It's kind of like, when I give this presentation to audiences, I'll say, some of you are expanding a little bit. You're getting bigger, but that doesn't mean you exploded into existence billions of years ago. God could have made the universe with finite size, and then he stretched it out a little bit since then. And I think that's probably closer to the truth. There's no reason to assume that the universe was the size of an atom when it started. That doesn't make sense to me. So they would argue from expansion of the universe. But probably the silver bullet, the one argument they'd say, well, this is just definitive proof of the Big Bang, is the existence of something that's called the cosmic microwave background. And that requires some explanation. Basically, if you could see microwaves, you could go outside at night and the sky would be faintly glowing with microwaves coming from all directions in space. And that's called the cosmic microwave background. And the Big Bang effectively predicted the existence of that type of microwave background. It predicted that you should see microwaves coming from all directions in space because, remember, according to the Big Bang, the universe started out very, very hot, and that's going to produce a lot of energy, a lot of light, heat, and so on. And when it cools off, when the universe stretches those light waves out, they become microwaves eventually. And this was discovered back in, I think it was 1964. Penzias and Wilson, they weren't really interested in astronomy. They were working for the Bell Phone Company, and they were trying to eliminate this noise that was coming from all directions in space. But Big Bang folks would say, well, you see, that's something that the Big Bang predicted, and there it is. And my counter to that would be, first of all, that's a very weak prediction because we now understand that basically any model of the universe would predict cosmic microwave background. If the universe has a sort of average temperature, it's going to have microwaves in it. You see, anything that has a temperature gives off radiation. Even you and I right now, as we're having this conversation, we have a certain temperature, 98.6, hopefully, and therefore we're giving off radiation. We're just giving it off in the infrared wavelengths. And so, there are certain cameras like the military folks use where you can actually see heat. You can see that infrared coming off. Now, the universe is much cooler than that, but it would have to emit microwaves if it has any temperature at all. And that's what we see. So it's kind of a weak prediction because every model would predict that. It's just that at the time, the competing model to the Big Bang, which is called the steady state model, they hadn't realized that their model would predict that too. And so the Big Bang saw the discovery of the CMB as a triumph of one model over the competing model. And then the other thing I would point out is the cosmic microwave background does not have the characteristics that Big Bang supporters expected it to have. They predicted that it should have very large variations. Let's call them hot spots and cold spots, and sufficient to act as seeds for galaxies to form, for the gas to collapse and form stars and galaxies and so on. And in fact, the variations we find are very, very small, much, much too small to account for the existence of galaxies and so on. They're at least 10 times smaller than the Big Bang folks predicted. So, one, it's a weak prediction, and two, it's not the right kind of cosmic microwave background. I think those two together really cancel that out as a successful prediction. If they want to call it a successful prediction, I would say, well, okay, but it's a pretty weak one, and a good model ought to make many successful predictions, and that's really the only successful prediction the Big Bang has ever made.
Yeah, and is it not just riddled with problems?
It really is.
Like,
yeah.
For example, like in your book, actually, this would be in the New Answers book too. You have a really good chapter on the Big Bang, and you mentioned the flatness problem.
Yes, that's just one example of something, and I picked that one because that's something that you'll find in standard textbooks. If they're honest, you'll find that. In other words, this is something that secularists are aware of. They're aware that this is a problem. They think maybe they have solutions to it. That's fine. But the flatness problem has to do with the rate of expansion of the universe. The universe is expanding at, you might say, just the right rate, such that it's not going to collapse in on itself, and yet it's not going to fly away, pushing all the galaxies to an extremely great distance in a short period of time. It's kind of traveling at its own escape velocity, really. It's kind of like if I took a baseball and I threw it up in the air, not very fast, it'll fall back down. If I threw it up really fast, it would zip away from the earth. I mean, if I had that ability to do that. And if I threw it at just the right rate, the baseball would travel at escape velocity, which means it would never come back to the earth, but it would continually slow down, but never quite stop and never quite come back. And the universe is traveling at almost exactly its own escape velocity, which means the galaxies will continue to move away from each other at the slowest possible rate that they could without actually collapsing back in on themselves. And it's remarkable that it's exactly that number. And in the secular view, there's no reason why it should be. The laws of physics allow any possible range of velocities from zero, or the universe could even be collapsing in on itself, or it could be expanding at an astronomical rate. And why is it balanced at just that right expansion rate? And so that would be an example of the flatness problem. We call that a flat universe or flat space-time. That's just one problem for the Big Bang that they have to explain among many. Right.
And that in a sense kind of fits into that whole anthropic principle concept that there's just so many things about the universe, about our solar system, that just point towards some kind of design. And no, I don't want to go down the road of intelligent design too much because, well, I believe in the God of the Bible, but certainly, I mean, we see design everywhere we look. It's amazing.
Yeah, that's certainly true. Yeah, and a lot of secularists even realize that. And I think, people talk about the atheistic scientists. I think most scientists probably are not atheists, but at the same time, they don't want to accept the God of the Bible. And so they're inclined to say, well, there's some sort of deity. Yeah, there's got to be some kind of mind behind the universe, but they really don't want to accept what the Bible has to say about that God. And that's a shame, because God's revealed himself. He's told us his characteristics and why he made the universe, and our relationship with him, and how we can have a better relationship with him, and so on. But people don't want to accept that. The Bible tells us that God's made himself known to everyone, but people suppress that truth in unrighteousness.
Yeah. And don't get me wrong, I really do appreciate the intelligent design movement and what's coming out of it. I think it's a great halfway point,
Yeah.
So, I mean, absolutely. So, okay, during the Big Bang, everything exploded into existence. Apparently, there should be equal amounts of matter and antimatter.
That's right.
Want to elaborate about that?
That's probably my favorite problem with the Big Bang, because it's so easy to understand. It's called the baryon number problem. Baryons are things like atoms, or electrons or not electrons, but protons and neutrons are baryons. And we can, the idea with the Big Bang is it starts as pure energy, and as that energy cools, it becomes matter. It becomes hydrogen and helium gas, protons and neutrons, which form atoms and make hydrogen and helium. And that's the one aspect that we can actually theoretically test in a laboratory, because we can take energy and make from it matter. That can be done with particle accelerators. You take, slam particles together at extremely high speeds, and from that energy you can produce new particles. But our experience has been that every time we take energy and turn it into matter, every single time we get an equal amount of antimatter. And antimatter is the same as ordinary matter, except the charges of the particles are reversed. So instead of having a positively charged proton in your atom and a negatively charged electron circling it, an anti-atom would have what they call antiprotons. They're negatively charged protons, followed by positrons, positively charged electrons orbiting around the outside. So it's the opposite of ordinary matter. And we can make antimatter in a laboratory. Every time you take energy and turn it into matter, you get an equal amount of antimatter. And every time you make antimatter, you get an equal amount of matter. You can't make one without the other. They have to go together. And so it would stand to reason then, if the Big Bang were true, and all the matter in our universe was once energy that changed into matter, it would have to be the case that there should be an equal amount of antimatter in the universe.
Right.
And that's a problem because when we look in the universe, we don't find antimatter. It's all matter. All the stuff that you see, all the stars and galaxies, those are all made of ordinary matter, and there are spectroscopic ways to discern that and so on. But that's agreed upon. We all agree the universe is matter only. There's only trace amounts of antimatter anywhere, and those are always made locally by basically natural forms of particle accelerators, and they're immediately destroyed. So the universe is matter only. If the Big Bang were true, it ought to be equal amounts of matter and antimatter. Where's the antimatter? And so that's a good question you could ask somebody who's a Big Bang supporter. You could say, where's the antimatter? Because the Big Bang should have produced it, and we just don't see it. Now, I happen to think that the fact that the universe is essentially matter only is actually a design feature, because when matter and antimatter touch, they destroy each other and they go back to energy, you see. And so if you ever meet a person made of antimatter, don't shake their hand, because that would be catastrophic for both of you. And so the fact that God made the universe matter only is because we wouldn't be able to have this conversation if he made it, equal amounts of matter and antimatter, because as soon as they touch, as soon as any two touch, they would release just an enormous amount of energy. And it is an enormous amount of energy too. That's why in all the sci-fi stuff, everything's powered by antimatter. It's an incredibly efficient source of power. That's why the Enterprise uses antimatter in its warp engines and so on. It's very destructive actually when it's unchanneled. So.
I was going to say that would make for a great supervillain in like an X-Men or one of the Marvel movies.
Yeah, if you can control it, yeah. Yep.
Oh boy. So in your book, Taking Back Astronomy, you also talk about monopoles. What are those, and how is that an argument against the Big Bang?
Yeah, monopoles are theoretical particles that basically, the long story short, the Big Bang predicts that they should exist, and they don't exist. And so that's long story short. Basically, the idea of a monopole is it's like a magnet, and just like the magnets you'd play with. I used to play with them when I was a kid, and you'd push them around and stuff. But magnets that you play with have a north pole and a south pole. And, north and south, they attract to each other, but north and north, they repel and so on. And most people are familiar with that. A monopole is a theoretical particle that has only one magnetic pole. It would just be a north or just be a south. And they don't exist anywhere. Every magnet we find in the universe has both a north pole and a south pole. Theoretically, you could have the laws of physics allow for monopoles to exist, and the laws of physics, as we understand them, indicate that these particles should be produced at extremely high temperature, much higher than even in the core of a star. But as you recall, the Big Bang is supposed to start with essentially infinite temperature. And so that ought to be hot enough to produce monopoles, because infinity is pretty hot. So,
right.
And yet we find no monopoles anywhere in the universe. It's kind of an interesting, I think it's an interesting aspect of physics that God chose apparently not to create them, because we do find the electric equivalent of that. Electric charge, you can have negative and positive, and you can find particles that are just negative. Electrons, for example, they're just negative, and protons are just positive, and so on. But with a magnet, every magnet in the universe comes with a north pole and a south pole, and there's not a single monopole that's ever been detected anywhere in the universe, and yet they ought to be abundant if the Big Bang were true. So that's called the monopole problem, if you believe in the Big Bang, and it's a feature if you believe in creation.
Now, this is a little bit off topic, but talking about magnetic fields, and doesn't Russell Humphreys have some kind of a planetary magnetic field theory that he talks about? Well, he made some predictions. I remember hearing him speak once, and I remember him making some predictions about Uranus and Neptune and their magnetic fields, and turns out he was right, which is, it's good science.
Yeah, that's right. He's got a model for, I think it's a very good model for that basically gives an indication of what the initial field strength of the planets would have been when God first created them, and he has good reasons for that I won't go into. But basically, given that God starts these planets with these certain magnetic fields, And magnetic fields naturally decay with time. They're caused by electrical current, as far as we know. Earth's got current going in its core and perhaps in its mantle, but mainly in the core. And that electrical current causes it to have a magnetic field. That's what produces magnetic fields. And as that electrical current encounters resistance, Earth's magnetic field decays. And so our magnetic field is actually getting a little bit weaker every year. And we've been able to measure this for almost 2 centuries now. We've been able to measure the decay of Earth's magnetic field, and it is decaying. There's no doubt that the total energy is dropping. Some people have tried to argue against that. Well, they say, well, it's just changing direction or something. No, the total energy is dropping. That's been measured. We'd expect that on the basis of physics. And the other planets in the solar system also have magnetic fields. Basically, Dr. Humphrey's model is able to say, given that God created the planets about 6,000 years ago, and given that that magnetic field's been decaying for 6,000 years, he can compute, based on the composition of the planets, what their current magnetic field should be. And he's right. He's able to get the right number for all of the planets, actually, including their moons, interestingly. And you'd say, well, that's fine, but the really interesting thing is, in several cases, he was able to predict it before the magnetic fields were measured. And so his model correctly explains the magnetic field of the Earth, of Mars, of Jupiter, of Venus, of Mercury. But those were known already at the time. And so you could accuse him of, backworking that into the model. But the neat thing is his model also predicted the magnetic fields of Uranus and Neptune before those magnetic fields were measured by the Voyager spacecraft. And Dr. Humphreys was right on in his prediction. The secularists were way off because they were assuming that those planets are billions of years old, and therefore the magnetic field should have petered down to almost nothing by now. And yet the strength that Dr. Humphreys predicted, he was right on. He was right about Jupiter's moons having evidence of remnant magnetism on those, and Mars having remnant magnetism. And he also predicted that Mercury's magnetic field should decay appreciably between when the Mariner spacecraft went past it in the 70s and when the Messenger spacecraft went past it just a few years ago. And that's since been confirmed. There is evidence that Mercury's magnetic field has decayed by about the amount that Dr. Humphreys predicted. And so I think that's a great example of somebody who, like myself, he's a Christian, he stands on the Word of God, and he's able to make correct predictions because he uses science the way it was intended to be used, based on the information God gives us in His Word and combining that with our best guesses about science. And he's able to make successful predictions about how the universe is today, and he's right on. But the interesting thing is, even apart from Dr. Humphrey's model, just the rate at which Earth's magnetic field is decaying is a very powerful evidence that our planet is not millions or billions of years old. The magnetic field decay, it's, as far as we can tell, it's an exponential decay. That's what we would expect. That's consistent with both the math and the observations that we've made. And based on the current rate of decay, based on that exponential fitting that curve back, if you work the math backwards, about 6,000 years ago, Earth's magnetic field would have been something like 20 times stronger than it is today, which is fine. That would give us a little extra increase from cosmic radiation. And so Adam and Eve would have enjoyed a superior climate to what we have today in terms of protection from cosmic rays and so on. But if you run the math back even 60,000 years, Earth's magnetic field would have been stronger than that of a neutron star, which is sufficient to rip the atoms of your body apart. So and that's just 60,000 years. That's not anywhere close to a million years, let alone a billion years, let alone 4.5 billion years. So it's a really tight constraint on the age of the Earth that is consistent with the biblical time scale, but not even remotely consistent with the secular time scale.
How do they deal with that?
Well, they would say, well, it can't therefore be an exponential decay. And so they would say, regardless of our observations, regardless of what the physics, what we'd expect based on physics, it must actually be an oscillating magnetic field. So they believe in something called a magnetic dynamo. And the idea of a dynamo is it's something like the alternator in your car. The alternator in your car takes mechanical energy and turns it into electrical energy that charges your battery. And so the idea is Earth has mechanical motions in its mantle and so on that somehow regenerate its magnetic field over time. I would argue there's absolutely no evidence for a magnetic dynamo going on in the Earth today. After all, the alternator in your car is a fairly sophisticated machine. It has to have parts working together in just the right way to effectively take mechanical energy and turn it into electrical energy. Now, we do think that during the flood year, continents were moving very rapidly. And so you could have something like that during the flood year, but there's no mechanism to produce it today. And all our observations today are consistent with a simple exponential decay, the kind that we would expect if there was just current in Earth's core that was generating the magnetic field.
Interesting. And so when uniformitarianism works for them, they're going to hold on to it. But when it doesn't, they just kind of scrap it.
That is so right. I've experienced many situations where that is the case. Uniformitarianism, of course, being the idea that rates and conditions are basically like they are today, or the present is the key to the past. And I find that, secularists will reject the Bible in favor of the assumption of uniformitarianism, because, you can't have a worldwide flood because there's no worldwide flood today. Everything's, being built by slow, gradual conditions. And yet, there are many examples of where you push those slow, gradual conditions and you still get a young Earth. And I find in those instances they're willing to throw out and say, well, I guess uniformitarianism doesn't work there, but we still think it works generally. That's very inconsistent, very, very inconsistent. Some other examples of that, the recession of the moon. The moon's actually moving away from the Earth at a rate of about 1.5 inches a year, and if you work that rate backwards, by the way, that's what the moon causes tides. It pulls on Earth's oceans, and then because Earth rotates faster than the moon orbits, the oceans get ahead of the moon. They pull forward on it, and that gives the moon energy and causes it to move out. So it's the tidal interaction that causes the moon to move away. If you run the movie backwards, that means the moon would have been closer to the Earth in the past. You run it back 6,000 years, the moon would have been 730 feet closer to the Earth. Not a big change. But if you run it back billions of years, and by the way, you have to do the math right on this. You have to use calculus to do it correctly, because as the moon gets closer to the Earth, the tidal bulges would get bigger, right? You're going to have larger tides, and that pulls on it faster, and they get even bigger, and it pulls on it faster, and so on. You do the math right, and you find that the Earth and the moon would have been touching at about 1.4 billion years ago, which may sound like a lot, but keep in mind, in the secular view, the Earth and the moon are supposed to be 4.5 billion years old. And so that's a problem, because I'm taking the current rate, and based on, good math that we understand, you run that rate back, and you find the Earth and the moon cannot be as old as the secularists believe. And, of course, you know what their answer to that is. They'd say, well, apparently the rate's not been constant. Apparently it's unusually fast today, in which case they're violating their own assumption of uniformitarianism. So, it goes back to what you said. They're willing to throw that out when it doesn't work, and yet they hold to it tenaciously when it gives them answers that they like.
Yeah, right. I guess another example that might be like the spiral galaxies and how they should be all wound up by now.
Yeah, in fact, I just last year, I guess it was about a year ago, I did a little computer simulation. I was curious to see how strong that effect is. The reason that works, by the way, spiral galaxies rotate differentially, which means the inner portions of the galaxy rotate at a faster angular rate than the outer portions. And so, it's like runners on the inside track. They have an advantage than runners on the outside of the track because they can complete the circuit in less time. And so spiral galaxies are constantly in the process of twisting themselves up. And they rotate rather slowly. So it would take something, on the order of, millions of years to complete a rotation. But the problem is, in the secular view, these spiral galaxies are supposed to be 10 billion years old. That's supposed to be a typical age for a spiral galaxy. And so I ran a computer simulation based on the current measured velocities of the stars to see how long does it take spiral galaxies to wrap up. And the answer is, in well less than 1 billion years, they are wrapped beyond recognition. So they're supposed to be 10 billion years old. But if they really were that old, they would not look anything like a spiral galaxy. They would look like a uniform disk, almost like a old-fashioned phonograph record, just like with a groove that just is really, really tightly wound. And of course, we find not a single spiral galaxy anywhere in the universe that looks like a 10 billion-year-old spiral galaxy should look. And so I think that's very compelling evidence that the galaxies are much, much younger than that, and certainly be consistent with the biblical time scale of thousands of years. And now that argument doesn't put a real tight constraint on it, because it could be up to, even up to millions of years, they'd still look spiral, but it certainly eliminates the secular idea that they're billions of years old. And in that case, the secularists would probably agree with me in terms of my math, but they would say, well, there must be some process that produces new spiral arms as the old ones are destroyed by this tight wrapping. And so if you've heard of spiral density wave theory, that's one explanation for how new spiral arms are allegedly formed. Of course, it's got problems of its own. You can always tack on a rescuing device, right? I mean, when the evidence doesn't fit your view, you can always come up with some kind of conjecture to explain it away. The nice thing about creation is you don't really have to do that. The evidence, I think, fits very naturally with what we'd expect based on what the Bible teaches. And the more that I examine the universe, the more I find that the Bible got it exactly right.
Amen to that. Another interesting, I guess, perhaps violation of the uniformitarianism idea is blue stars.
Yeah.
They burn really hot, really fast, but we still have them.
That's right. Yeah, blue stars are the most luminous type of stars, or the brightest stars that exist are blue stars. And they tend to be the most massive, too, the heaviest stars. And so in a star is its own fuel, right? It's made of hydrogen, and bits of helium, and it's able to fuse that hydrogen into helium as a power source. And so it's constantly using up itself, its own material, converting it into helium. And blue stars use up that rate. They have a very fast rate of using up their fuel because they're very luminous. The candle that burns twice as bright lasts half as long, and blue stars are the brightest candles of them all. They really burn like crazy. And so the way I like to put it is blue stars are kind of like the SUV of the star world. They have a very large gas tank, but they get very poor gas mileage, and so they just can't go very far in time. And if you do the calculations, the very hottest blue stars can't last more than something like 1 million years. And again, that may sound like a lot, but keep in mind that secularists believe the universe is 13.8 billion years old. So, over 1,000 times longer than that. And so there shouldn't be any blue stars left if they were that old, if they were billions of years old. And yet we find lots of blue stars all throughout the universe. You can go out on a clear night, look at Orion's belt. Those are blue stars. Those are O-type stars in Orion's belt. Those are the hot ones that can't last billions of years. So we find those throughout the universe. In fact, spiral galaxies, the spiral arms, have a very high proportion of blue stars compared to the bulge. And so that's a further indication of the youth of the universe. The spiral galaxies really just are the death knell of this idea of billions of years, because they got several different lines of evidence that indicate that they're much younger than that. And again, my secular colleagues, I mean, the math is so conclusive on this, they won't even bother to argue that blue stars can last billions of years. They know better. And so their argument would have to be that, well, apparently, as old blue stars die off, new ones replace them somehow. And so that goes back to this idea that, gas somehow collapses in on itself and somehow is able to overcome gas pressure and magnetic fields, and somehow is able to overcome angular momentum and form a new star, which we see not happening anywhere at all in the universe, and which we know has physics problems. But see, my secular colleagues have to believe that because we see blue stars, and they're unwilling to concede the possibility that the universe might be young. So they're forced into believing in something that really just doesn't make a lot of sense.
Yeah. Now, okay, so the blue stars are burning really hot, and we really shouldn't see any at all. Aren't there many really hot planets that, they should be cooled off by now, and same type of idea with some planets? Yeah,
it's a similar concept. Now, planets don't produce their own heat. So, stars, of course, are producing power by converting hydrogen into helium, but stars only have so much fuel. Now, with planets, they start with a certain heat, their heat of formation in the secular view, and they just cool off with time. Planets just cool off with time. Once they form, allegedly in the secular model, they radiate that heat to space and they cool off. It's kind of like a potato when you take it out of the microwave. At first it's nice and warm, and you can feel the heat coming off of it. And as that heat comes off of it, it loses energy, and the potato cools off. And it doesn't take real long for a potato because it's pretty small. Now, a planet's much larger, and so a planet theoretically could last, a lot longer and continue to give off heat. But it can't do it for billions of years. And so planets like Jupiter and Saturn and Neptune, for example, they all have lots of internal heat. The three of the 4 big planets in our solar system have lots of internal heat. More than you could really explain if these planets are billions of years old. Why haven't they cooled off by now? And by the way, that's true of planets like the Earth as well. But with the Earth, you could argue that radioactivity continues to produce new heat. You see, radioactivity does produce a small amount of heat, and my secular colleagues assume, although I don't know that they've ever done the calculation, but they assume that the reason the Earth's still warm is because it's got radioactivity. But Jupiter and the big planets, they don't have radioactive elements. They're made of the light stuff. They're made of hydrogen and helium with only trace amounts of anything heavier than that. So you can't use that explanation for the big planets, and yet they're still warm, or at least 3 out of 4 of them are warm. And why is Uranus not warm? I think God did that just to confuse the evolutionists. Because Neptune and Uranus are almost identical in every way, and yet Neptune is warm and Uranus is cold. And so I just think that's an example of God's diversity. I'd expect that kind of diversity in the universe, but it makes no sense if those two planets have a common origin, why they should differ so much in temperature, why Neptune should be so warm. Neptune actually gives off 2.6 times as much energy as it receives from the sun. So it's warmer, much warmer than it should be if it were billions of years old. It's dumping that energy into space. So that's another indication that the solar system is much younger than the billions of years that my secular colleagues believe in.
Huh. Okay. Another thing I read about, and at this point I can't even remember where I read it, but star clusters, are they not also a problem for an old universe?
Maybe. I'd have to look into the details of that. I know it's a problem getting stars to form in the first place, so that's a bit of an issue. And I do remember in grad school when we were talking about how, because the idea is that like these clusters like the Pleiades, for example, the Seven Sisters, which you can see in the winter skies off the constellation Taurus. It's a group of about a few hundred stars there. You can see 7 of them naked eye, and the idea, but they're blue type stars, O and B type stars, mostly B type, which are relatively hot. And they have to be recent in the secular view because they can't last billions of years. But there's a problem though. Once you make an O-type star, it has very powerful stellar winds, which would tend to disperse gas into space even further and would tend to prevent the formation of other O-type stars. And so one of the issues that we covered that when I was in grad school is how do you possibly produce a cluster of all these blue-type stars? And I've never used that as a knockdown, drag-out argument because there might be an explanation for that makes sense. But I'm not sure that that's easily explained in light of what we know about physics.
Right. Also, another problem. What about supernovas? I've read that if the universe is really as old as they're believing, 14 billion years, that we should have far more supernovas that we can see than we actually do. Yes,
that concerns what's left over from the supernova. After it explodes, it leaves what we call a supernova remnant, and that's basically, when the star explodes, that gas is released into space, and you have a very rapidly expanding shell, and it's very hot, of course, because the supernova involves tremendous energies. And we do see some of these supernova remnants. We see some in our galaxy. We see some in other galaxies. But the idea is, we know roughly the rate at which supernovae occur because we can watch them. We can see them happen from time to time. We see them occasionally in our own galaxy, about once per century in our galaxy, and other galaxies have rates that are kind of comparable to that. So we know the rate at which it happens. And if the universe were billions of years old, and you get a supernova remnant every century, well, you ought to have a lot of supernova remnants in this galaxy and in other galaxies. And we see actually very few. And up until recently, I've been kind of reticent to use that argument because I wasn't sure how strong it was. I wasn't sure, should we really be able to see supernova remnants, how clearly and so on. But I must admit, I've changed my mind on that. I now think it's a very strong argument because I got to hear a presentation by Keith Davies at the Christian Research Society meeting, and he's done some research on supernova remnants in I think it's the Large Magellanic Cloud, which is a nearby satellite galaxy to ours. And it's interesting because we know the rate, again, at which these supernova remnants occur, and we have a nice view of this galaxy because there's nothing blocking it. I can't see it from where I live because I'm in the northern hemisphere, but if you live in Australia, you get a spectacular view of that galaxy, very clear. And they've measured the number of supernova remnants in that galaxy, and it's consistent with about 6,000 years age for that galaxy. You could push it maybe to 7,000, maybe 8,000, but you can't push it anywhere close to millions or billions of years. And so I think supernova remnants are a very powerful confirmation of the biblical timescale of a few thousand years.
Is there any other arguments that you might want to mention that show that the universe is actually younger than 14 billion years?
Oh, sure. I mean, there are lots of things like that. In fact, there's evidence for youth everywhere in the universe. But some arguments are stronger than others because in some cases you could imagine a process that would, that could regenerate whatever it is. But comets, for example, I think comets are a pretty good argument for the youth of the solar system. Comets can't last millions or billions of years. Comets are made up of ice and dirt, and they orbit the sun in elliptical paths. They kind of go far away. But when they come close to the sun, that icy material gets vaporized. It gets blasted away by solar heat and radiation. And that's what forms a comet's tail. And so every time you see a comet, it's getting smaller. It's losing mass. And they just can't do that for that long. They don't have that much mass available. A typical comet, the size of the nucleus, would be just a few miles across. And,
oh, wow.
Yeah, they're not very big. In fact, the largest comet we know of was Hale-Bopp, and it was about, I'm going to mess up the number now, but it was, tens of miles across, maybe 40 miles or something like that. But that's as big as they get, and most of them are much smaller than that. So they're just not that big, and they just don't last that long. I used the SOHO spacecraft in my doctoral research, and SOHO is designed to point right at the sun, and it's got a special instrument that can block sunlight, and it sees comets as they go back behind the sun. And I've seen many comets that have gone behind the sun, and they are totally obliterated in one pass.
Huh.
Yeah, I've seen comets that go behind the sun, and that's it. They are no more. Maybe you heard, I think it was about a year ago, they had Comet Ison that was supposed to come around and be a spectacular comet. It turned out to be kind of a dump.
Right.
But there is no more Comet Ison. It's gone. It went behind the sun, and it was destroyed by the heat and radiation. It did not survive the trip. So comets, they just don't last that long. We know that. We can see them disintegrating. And yet, if the solar system is billions of years old, why do we still have comets? My secular colleagues would say, well, there must be a comet generator that makes new ones, which they call the Oort cloud. If you've heard of the Oort cloud, it's the idea of trillions of, let's call them potential comets, orbiting way beyond Neptune, where they're not detectable, in kind of a spherical orbit or quasi-spherical, and then or circular, and then every now and then one of them gets kicked into the inner solar system and becomes a brand new comet. And so again, they've got this undetectable comet generator that kind of saves the day and allows them to believe in billions of years, despite evidence to the contrary. But I would say that there's no evidence for an Oort cloud. That's just something they've invented. They just pulled that right out of the hat. And is that really very scientific, just to sort of invent things like that to explain away the evidence? I don't think so. I think the evidence is a lot more consistent with the biblical time scale of thousands of years. Lots of things like that, too, that, dust in the solar system and, solar wind and radiation tends to clear out dust. And so if the solar system were billions of years old, why does it still have so much dust? And, some of these arguments are stronger than others, but I think all of them are at least indicative of the biblical time scale of thousands of years.
Right. Okay, so here's the question that everybody asks you over and over and over. If the universe is billions of years old, and we can see light coming from these stars billions of light years out there, doesn't the fact that we can see that light from billions of light years away, doesn't that prove that the universe is billions of years old?
Yeah, I do get that question a lot. The answer that I'm going to give, and I could be wrong about this, but there's more than one way to do it. There's more than one way to get light to travel very large distances in a shorter amount of time than my secular colleagues would like to admit. But the answer that I think is the right one, it has to do with Einstein's theory of relativity, and it gets a little bit complicated, but basically, the speed of light in one direction is not something that we can measure. Anytime we actually true and blue measure the speed of light, it's always on a round trip. Like I take a light beam, shoot it out to a mirror, bounce it back, and get the time going out and and back. And the entire trip takes, let's say, 2 seconds. People would assume often that it takes 1 second to go out and 1 second to come back. But according to Einstein, that's not something that can ever be proved or measured. He said the one-way speed of light, the speed of light on a one-way trip, is something that we actually define. And it's kind of like the number of inches in a foot. Why are there 12 inches in a foot? What property of nature causes that? Well, no property of nature causes that. Human beings decided that that's the number they wanted to put. And it's the one-way speed of light. It's counterintuitive because you'd think, well, it has to be one speed or the other. it's counterintuitive, but actually the speed of light can be defined such that when it's moving toward an observer, it's infinite. And then its speed, in different directions is slower than that. And this is what's called an anisotropic synchrony convention. Anisotropic means different directions. And synchrony convention is how you define time at different places in the universe. The bottom line is you can get light from the most distant galaxies to the Earth in no time at all. And this is all orthodox physics that Einstein understood and would agree with. And in fact, there have even been secularists that have used that model for different reasons. But Stachel and Sarkar, for example, wrote a paper some time back where they pointed out that you could define the speed of light to be instantaneous when it's moving toward the observer, and that would allow you to mark time in a slightly different way than is standard. But it's still, it works, and it's perfectly legitimate physics. And the details are a little bit complicated. But I have written on this. In fact, it's in one of our latest books called Creation Basics and Beyond. I've got a chapter that gives what I just told you, but in more detail, and gives you a little bit more background information on that. Bottom line is you can get light here instantaneously, actually. It takes no time at all to get light from the most distant galaxies to the Earth, and you can do that in a way that matches with known physics.
Okay. Yeah, I have that book. I just haven't cracked it open until right now.
Okay. Well, there you
go. Too many books and so little time.
Yeah, I understand. I have that problem too.
So, I guess on that same note then, we have distant large galaxies with old stars in them. Does that fit into that same theory, basically? We can see out in space, we see these old stars, and we should be seeing a young star if that light has been traveling here this whole time, right?
Well, actually, we don't see. When you look at a star, it doesn't come with a label telling you how old it is. Secularists would like you to believe that. They'll say, look at these stars are very old. Well, they don't know that. They don't know how old the star is. They don't know how long it's been around. But I would say that we find at all distances in space evidence of youth. For example, red or blue star. We talked about previously. Blue stars, they can't be old. And yet we find blue stars nearby. We find blue stars in the farthest galaxies, at least as far out as we can detect them anyway. And so that tells me that all these galaxies are young. They have to be because they have blue stars in them. And you'd say, well, what about the red stars? Well, they're young too. It's just that red stars have the potential to last a lot longer than blue stars. But just because a star is red doesn't mean it's old. It just means it has the potential to last a very long time. Like when I get a Toyota Camry, brand new, I know it's going to last a long time because they're well made. I know it's going to last, hopefully, 200,000 miles, but that doesn't mean it starts with that, with that distance on it. And so all the stars, I would say, are young, and with blue stars, they have to be young.
Doesn't the Big Bang also have a starlight time problem?
Yeah, it sure does. It's called the horizon problem, and it's the same type of problem as a starlight problem. But basically, in the Big Bang view, the universe is supposed to start off with hot spots and cold spots in different places when the universe is very, very small. And today, the temperature fluctuations are very small, and so the hot spots and cold spots have all evened out. And the only way that can happen is if light travels or energy travels from the hot spot to the cold spot, and the fastest that you can travel is the speed of light. That's the fastest speed. And so, and yet in the secular view, there hasn't been enough time for light to travel from the hot spots to the cold spots, because these could be on the opposite sides of the visible universe today. And so even in the secular view, they have an issue of trying to get light to travel a greater distance than seems possible within their model. And so I think actually when it comes to light travel time, we're in a much better position than they are, because I think the model that I mentioned to you previously, the anisotropic synchrony convention, that will allow creationists to get light from the galaxies to Earth in no time at all. But it won't solve the Big Bang's light travel time problem. So really, when people ask about light travel time problem, I'd say, well, we don't have that in our model. We've solved that. How's it going for you?
Okay. Well, okay. So if the universe really is young, what does that mean? I mean, what do we do with that now?
Well, I think it's a confirmation that the Bible's right. It tells us that the Bible's right about the age of the universe. And that's one of the big issues where people say, yes, I understand the Bible's right about Jericho. That's been archaeologically excavated. We know that happened in the city of Ai and so on, and all these other places. I mean, archaeology has always confirmed Scripture, at least eventually. And, we know that happened. But really, did God really make in 6 days? And did he really make just a few thousand years ago? Doesn't science prove billions of years? And the answer is no. Science is our friend. Science confirms the history that the Bible teaches. And I would suggest, therefore, that gives us increased confidence that the Bible really is what it claims to be. It really is the Word of God. It can be trusted, not only in matters of science and history, but it can be trusted on matters of salvation. When the Bible tells us that we need to place our faith in Christ, we need to repent of our sins and receive Christ's payment for our sins that he paid for on the cross, we can trust that's the only way to eternal life.
Yes. Amen. Well said. Okay. So, friends, many of the things we've talked about today, I've been pulling much of this from Jason Lisle's book, Taking Back Astronomy. Awesome book. It has so many things we've talked about today in more detail and so much more. Colorful pictures, glossy pages, just a great work. Good book. Jason, tell me about Discerning Truth.
That's a book about how to spot fallacies in arguments. And a lot of people have said they've really benefited from that book. It's an easy read. There's very short chapters. There's one fallacy especially fallacies that come up in debates on origins, because I find that my evolutionary colleagues, I love them, God bless them, but they make mistakes in reasoning left and right. And this book is to help you to spot those errors. Like equivocation, where they change the meaning of a word within an argument, like the word evolution, which can mean descent from a common ancestor, or it can mean change in a generic sense. And a lot of times evolutionists will try to prove one type of change using the other, and that's an example of an equivocation fallacy. Or reification, where they give concrete or personal characteristics to an abstraction, like nature designs, and things like, well, no, nature doesn't design, God designs. Nature can't do that because it doesn't have a mind. Those are examples of fallacies that often come up in evolutionary arguments, and that book is a very easy read, and it's got a couple of practice tests in the back with an answer key, so you can check and see how you did. You can practice your fallacy detection skills by reading that book.
Very cool. Yeah, I've read that book as well and love it. That's why I wanted to ask Jason about it. Another book that I have of yours, Jason, is The Ultimate Proof. Now The Ultimate Proof of Creation, Resolving the Origins Debate. I have not read that one yet. Tell me about that.
Oh, I think you're going to like it. That's my personal favorite book of all the ones that I've written. That one, I just have a special love for that. What it does is it shows you that the Christian worldview, and really only the Christian worldview, can make sense of anything, from science to mathematics to logic to morality. You see, what happens is we tend to get caught up in these details of arguments, the details of the science and star formation and things like that. That's fine. There's a place for that. But one of the things that I like to challenge my secular colleagues is, how would science even be possible in a chance universe? You see, science presupposes that the universe is orderly and logical, and that the human mind can understand the universe, and that our senses are reliable, and so on. But these are things that only make sense in the Christian worldview. As a Christian, I have the right to assume that my senses are basically reliable because they've been designed by God. My mind can be rational because I'm made in God's image. The universe is logical and orderly because God upholds it in a consistent fashion and has promised to do so from His Word. And people would say, boy, is it really that easy? And the answer is, yeah, it is. You see, the Bible tells us in Romans 1 that God has made Himself known to everyone, and that's why everyone is able to do, to some extent, science, and they're able to reason to some extent, and they're able to breathe and get up in the morning and brush their teeth because they rely upon the continual upholding that God does with His universe. And they believe that because in their heart of hearts they really do know God. But the Bible says they suppress that truth in unrighteousness. And so unbelievers will take their knowledge of God and squish it down and pretend that they don't believe in God. But what I do is I expose their suppressed belief in God by showing that what they believe in, science, rationality, and so on, really only makes sense if the biblical God is who He says He is, if the Bible really is true. It's a really powerful argument for biblical creation. I dare say an irrefutable one. I've never had anyone be able to come back from the argument. And that doesn't mean that people will necessarily cry uncle and say, well, you got me there. But the way I like to put it is, just because you don't cry uncle doesn't mean I don't have you in a headlock, right? I mean, I've got you. The argument is a killer. And whether or not people will admit it, that's a pride issue. But in terms of rationality, only the Christian worldview can account for those things that are necessary for reasoning. The book's got much more to it than that. That's the basic premise of it. And the person who was really good at using this type of argumentation is our Lord and Savior Jesus Christ. In his earthly ministry, he was very good at pointing out that the argument of his opponents doesn't even make sense. He could take an argument and turn it on its head. And I've heard a lot of people say, boy, I sure wish I knew how to do that. Well, that's kind of what this book is training you to do. It's training you to see things biblically so that you can see that all truth is in Christ. And if anyone dares to challenge God's word, they're in a position that they can't really know. Ultimately, they wouldn't be able to know anything apart from the truth of the Bible.
Wow, cool. I'm all over that. I'm going to be reading that pretty quick, and perhaps I might even try to con you to come back on the show and talk more about it.
I'd be happy to do that.
Excellent. Well, Dr. Lisle, it has been an honor and a blessing to have you on the show. It really has.
Well, thanks. I appreciate you having me on. Thank you very much.
All right. Well, there you have it, guys. That's Dr. Jason Lisle, again, of the Institute of Creation Research. Guys, I really can't speak highly enough of Dr. Lisle. I really enjoy his books. You can find many of his talks on answersingenesis.com. There's many of them in video form. You got to check them out. And yes, his books are fantastic. Changing subjects a little bit here, I wanted to make an announcement. There is a conference coming up on January 1st, 2nd, and 3rd. It is the Student Worldview Weekend Contend 2015 conference. Guys, this is an apologetics / worldview conference that is put on by Worldview Weekend. That's Brandon House's ministry. I cannot speak highly enough of his ministry. In fact, I get many ideas for various podcast topics from Brandon House and his ministry. He really does a fantastic job talking about worldviews and apologetics. He gets into some more, in his podcast, he gets into more current issues as well. But anyway, I'm not talking about his podcast, although if you want to check out his podcast, you really got to check it out too. It's fantastic. But this Worldview Weekend Student Contend 2015 conference, again, it's January 1st, 2nd, and 3rd of 2015. It is in Collierville, Tennessee. Guys, it is free. It's got a great lineup of speakers. Of course, as one might expect, there's going to be Brandon House there. There is Mike Riddle of Creation Training Initiative. Guys, he's got a podcast, Creation Training Initiative. I think Mike Riddle used to be part of Answers in Genesis. He's been floating around doing various creation, evolution, young earth creationism type talks. In fact, I've had the opportunity to meet him in person when he came and spoke at our church. Probably about 5 years ago. Probably does not remember me at all. That's fine. Amazing guy. Great information. He's going to be speaking about creation and evolution, I'm sure. Jesse Johnson, Jason Pratt, Jared Carlson. He's the son of Ron Carlson. Great apologetics. Also Mike Abendroth and Justin Peter, who I am going to have on a soon future podcast talking about the Word of Faith movement and some of the doctrines and some of the teachers that circulate in that movement. But anyway, this conference really, guys, it's free. It's free. It's a 3-day conference. It's jam-packed with great information. Really a great opportunity if you've got high school to college age, youth groups that you'd like to take up there. Guys, seriously, this is one of those that you cannot miss. If you go to 2015.com. There's more information there. I just want to mention it. It's just a great opportunity. And again, it's free. Great conference. You guys really got to check it out. I wish I could make it. I really want to make it. I don't think it's going to happen, though. But guys, I'm all the way in Colorado. Many of you are far closer to that. And so I'd say, hey, and even if you are farther than me, this is a great conference to go to. They had one in 2014, and they packed the house, and I've heard nothing but good about it. So, yeah, check that out. Again, www.contend2015 or 2015.com. And so anyway, that's pretty much it for today, guys. I will catch you again next week with another podcast. Thanks for listening, and we'll talk to you next week.